What is P2? Do you know P2? Polynomial of degree 2. Polynomial of degree 2. So P2 in R is the span of x2, x, and 1. And 1. So what is the dimension of P2? What is the dimension of P2? 3. I have a few more definitions. You know these definitions or you have heard them before. Rank. Rank of matrix is the dimension of the vector space generated by its column. So in other words, if I have a matrix, I put all its column side by side and make a vector space. Then I find out what is the number of, what are the bases, how many bases do I have. Then that dimension will tell me that what is the rank of a matrix. This can be actually expressed in this form. In other words, a rank of a matrix is the number of, you complete it, is the number of
linearly independent columns?
Yeah, number of linearly independent column of the matrix. Any rank 1 matrix of A belonging to R m by n can be written as A is equal to x y transpose if x belongs to R m and y belongs to R n. We can actually generalize it by considering in a complex form. Any rank 1 matrix of A belonging to C m by n can be written as A is equal to x, y Hermitian if x belongs to Cm and y belongs to Cm. Any rank 1 symmetric matrix can be written as or any rank 1 Hermitian matrix can be written as X multiplied by X Hermitian. So Donna, if I have a rank 1 matrix and if I want to calculate its basis, how many basis vector can I find?
No, one.
Only one. Only one.
Yeah.
Right? Only one. And from now on, when I use the word rank, I mean column rank, because later we will see that we can actually define the row rank as well. But the word rank is from now on for the column operation, columns. This is that. Sum and intersection of subspaces. Given what does this mean?
A vector space in a field.
Yeah, a vector space over the field, and what does this mean? What does this notation means? Vector space R, I mean not real number R, but just R, and vector space S are subset or subspace of vector space V, right? Now we want to define what is R plus S and what is R intersected by S. R plus S is the R plus S's that R's belongs to R and S elements belongs to S, and intersection of R and S are an element like U, where U belongs to R and U also belongs to S. Two very clear conclusions from this is obviously R plus S is also a subset of V, and R intersected by S is a subset of V. You know that this sign underneath this subset means that they can be also equal. So now we are defining something which is called direct sum. Is equal to T is the direct sum of R and S if you have two conditions. R intersected by S is 0 and R plus S is T. Do you remember from set theory that if this condition is satisfied, in other words, if we have the direct sum, what do we call R and S? Then R and S are called complement of each other, complement of each other in T. You remember we in probability we had this in statistics. This is the S. If this is A, this is B. If there is nothing common between them, if there is no intersection, if we add them together, we will get S, right? So and they were called complement of each other. A prime was B and so on. Well, I mean, this was like very. You know, there are two other things regarding to this direct sum. Given that R plus S, I mean direct sum S is T, given that the direct sum of R and S is T, then 1. There exists a T belonging to T which can be written uniquely in the form of T is R plus S with R belonging to R and S belonging to S. The second thing is the dimension of T is the dimension of R plus the dimension of S. Again, this was something. Are they clear or obvious? Laura?
I haven't. Yeah, I'm still writing, so I haven't
Okay.
yet parsed it.
Yeah, okay. Finish writing, digest it, and okay, I want you to think about this. Prove it. Show me your proof. That for any T belonging to T, we can create a unique form of R plus S. For the second part, we need to know one theorem, which I will tell you. So we'll try to prove the first one.
Won't one of them necessarily be no.
I mean, it's a theorem. I mean, it's true. So there is no.
Yeah.
Look, let's do this one. I mean, in general, because you might have similar to this one in the, let's say, homeworks and so on. So how do we do that? It says that we can write it uniquely, right? Let's say we cannot write it uniquely, and we come to the conclusion that that cannot be true. This is one way of proving it, right? So let's say T is R1 plus S1, which is also R2 plus S2, which means that T is not created uniquely. It can be created by any combination. Is it true? So then from here we understand that R1 minus R2 is S2 minus S1. where R1, R2 belongs into R, and S1, S2 was belonging to S, right? So, because this is a vector space, this is a vector space, so addition of these two is in R. Addition of these two is in R. So, we understand that R1 minus R2 belongs to R, and S2 minus S1 belongs to S. However, we know this. Is 0, then what we understand is
Possible.
the assumption is wrong and the opposite is always true. So it means they can be written in the unit form. For the second part, for the dimension, we need to know this small theorem, and I'll just write the theorem, and then you can easily say that, oh, here is the answer. There's a theorem which says that the dimension of R plus S is the dimension of R plus the dimension of S minus the dimension of R intersected by S, which this is 0. So the result is proved. So, in other words, here R1 is equal to R2, S1 is equal to S2. So, we showed that this is uniquely. It can be written in a unit form. We proved that the dimension is the dimension of R plus dimension of S. And then we start by talking about something very new chapter, which is linear transformation. Let V vector space F over the field F and vector space W over the field F be vector spaces. Then we define L from V to W is a linear transformation if and only if we have this. L alpha V1 plus beta V2 is alpha L V1 plus beta L V2 for all alpha and beta belonging to F, and V1 and V2 belonging to V. The vector space V is called the domain of L, while W is called the codomain. So, what it says is that a linear transformation is a mapper. It maps from vector space V into vector space W. And this mapper is a linear transformation if we have this condition. We have seen this one in a very shorter form. We have seen this one in a very shorter form. Do you remember how we have seen it in a shorter form? If you have taken the DSP course, usually when we had the system, we said that the system is a linear system. If X belonging to our system S and Y belonging to system S, then we came to the conclusion that AX plus BY should be also in S. Do you remember this linear property? So this is a general form of writing it. In other words, L is a linear transformation if addition of two vectors and then we give it into our mapper and we get one answer, it will be the same as giving each of the vectors separately to the mapper, and what we get in the codomain, we add them, we will get the same result. Also, scaling. If we are scaling our vector and then we give it to the mapper, we will get the same results as we just give it to the mapper and we scale the output. Right? So we can show it both in one line like this. And this one, we start from V, we call it domain. And we are mapping it into the new elements in W, which we call it a codomain. So what we want to do in this chapter, we want to talk about what linear transformation does for us, let's say on bases and all other things that we have discussed in the vector space. Which we will talk about it on Friday. And also on Friday I will assign you the next homework. Or we can assign it even now. Have you started the previous homework?
Yes.
Any problem?
Yes.
Good. So it means that you are busy. So for the next homework, do you want to have the odd numbers or even numbers?
Odd.
Odd numbers. I don't know how many questions we have, we will do the odd ones. So if it is 5 questions, you will have 3. Whereas you could have the it could be 2. Right? So I will put it on a module regarding to the second chapter. Do you have any question?
For the previous ones, we chose the number, right? So
Yes, you chose the numbers.
Yeah,
This time
so,
I chose the numbers.
Okay.
So odd numbers. Then it means that in the, maybe next week I can solve those questions which are not homework in the class. If you have no question, this is the end of the lecture for today.